All right, so new problem. Let's say you have 5 flavors of ice cream and you want to select 2 different flavors to place on top of an ice cream cone. How many different ice cream cones can you make? Now this is no different from saying you have 5 runners. How many ways are there to assign awards for first and second place? It's the same problem. I just changed 5 runners to 5 flavors of ice cream. I just changed first and second place to selecting 2 different flavors. So you can do this with a tree diagram. You have 5 branches to start with. You have 5 choices for your first flavor, followed by 4 choices for your second flavor, 4 remaining choices. So you would have 5 branches, each of which would have 4 branches. So after you choose your first flavor, well, there are 4 remaining flavors to choose from. So 5 times 4 gives you 20. So that's the answer. Another way to think about this, though, is that this would be 5p2. We have 5 things. We want to take 2 from them. And we want to arrange them where order is important. So why is order important? Well, order is important because if you have an ice cream cone and you have chocolate on top and you have strawberry on the bottom, if you have that ice cream cone, well, you have to eat chocolate first. You can't eat strawberry first. That would make a mess. So that's a different cone than having strawberry first and then chocolate second. In this scenario, you have to eat strawberry first. Then you got to eat chocolate. So this is a permutation problem. It's like having first place followed by second place. First place followed by second place. Bob finishes first, Joe finishes second. That is different from Joe finishing first and Bob finishing second. So it's important to make that distinction. All right. Now, so new problem. Let's say you have 5 flavors of ice cream and you want to select 2 different flavors to place in a big bowl. How many different bowls of ice cream can you make? Now, how is this different from the last problem? Well, here's why it's different. If you have your 2 ice cream cones, if you have 2 ice cream cones, strawberry on top, chocolate on the bottom, that is a different cone from having chocolate on top and strawberry on the bottom. These are due to 2 different ice cream cones. Here you have to eat strawberry first, chocolate second. Here you have to eat chocolate first, followed by strawberry. Now, both of these ice cream cones correspond to the same bowl. If you put a scoop of chocolate in a bowl and a scoop of strawberry in a bowl, a big bowl, so they're not even touching, or you don't have one on top of another. So there's your big bowl. If these 2 flavors are in a bowl, you can eat whatever you want first. You could eat chocolate first, you could eat strawberry, doesn't matter. So, each bowl corresponds to 2 different cones. Or in other words, 2 different cones produce the same bowl. Okay, so if we want to figure out the number of bowls we can make, if we if we have 5 flavors and we want to select 2 different ones to put in a bowl, well, we got to say, all right, if we take 20 cones and then divide by 2, that will give us the number of bowls. So the reason is each of these, so 20 cones, so where the 2 comes from, we have 2 cones per bowl. So if you have 20 different ice cream cones, well, if you have pairs of cones corresponding to the same bowl, well, there's going to be half as many bowls as there are cones. You're going to take 20 cones and you're going to divide by 2 cones per bowl to get 10 bowls. So there's fewer bowls than cones. That makes sense. There's more cones than bowls. You have half as many bowls as you do cones, because 2 cones correspond to the same bowl. Now, let's say you have a bowl with 3 different flavors of ice cream in it. How many cones could you make out of that bowl? Well, let's say you got chocolate, strawberry, and vanilla in a bowl. Big bowl. Looks like that. Okay, so let's say you have chocolate, strawberry, and vanilla in a bowl. I want to know, how many different cones could you make out of this? Well, you could use chocolate as the first scoop on your cone, strawberry as the first scoop on your cone, or vanilla as the first scoop on your cone. If you chose chocolate first, you could choose strawberry to be second. If you choose chocolate first, you could choose vanilla to be second. If you choose strawberry first, you could choose chocolate to be your second. If you choose strawberry first, you could choose vanilla to be your second. If you choose vanilla first, you could choose chocolate to be your second. If you choose vanilla first, you could choose strawberry to be second. Now, if you choose chocolate followed by a strawberry, your last choice has to be vanilla. It's what's left over. If you choose chocolate followed by vanilla, your last choice has to be strawberry. If you have strawberry followed by chocolate, your last choice has to be vanilla. If you have strawberry followed by vanilla, your last choice has to be chocolate. Vanilla followed by chocolate, last choice is strawberry. Vanilla first, strawberry second, last choice has to be chocolate. So, we have 3 times 2 times 1, or in other words, 3 factorial, which is 6. We see we have 6 ways to arrange things where order is important. So 3 factorial here. 3 factorial is the number of ways to arrange things where order is important. So what we just found out is that if you have a bowl with 3 flavors in it, it corresponds to 6 different cones. Or in other words, if you're choosing 3 flavors, 6 different cones all correspond to the same bowl. Now, let's say you have 5 flavors of ice cream and you want to select 3 different flavors to place in a big bowl. How many different bowls of ice cream can you make? I'm going to use the same technique we used on this problem to solve this one. First, I'm going to say, well, how many cones could we make? So I'm not going to figure out bowls first. I'm going to figure out cones. Well, you could use a tree diagram. You have 5 choices for your first scoop, followed by 4 remaining choices for your second, followed by 3 remaining choices for your third. So you can make a tree diagram. 5 branches, followed by 4, followed by 3. Gives you 60 branches. So that's how many cones we could make. So we could make 60 cones. But now we just saw that 6 different cones all correspond to the same bowl. So there are a lot fewer bowls than there are cones. In fact, you got to do 60 and you got to divide by 6, which is the number of cones per bowl. So if 6 different cones correspond to the same bowl, there's 1/6 as many bowls as there are cones. So this time you got to take the 60 cones and you got to divide by 6 to get the number of different bowls. And that gives you 10 bowls. So there are 10 different bowls. Now let's think about how we got that 60. The way we got that 60 is we did 5 times 4 times 3. Let's think about how we got that 6. That 6 was 3 factorial. Or in other words, what we did is we did 5. We did 5p3 divided by 3 factorial. So 5p3 gave the number of cones. 3 factorial gave the number of cones that correspond to the same bowl. So 5p3, that's ways to arrange 3 items. Ways to arrange 3 items taken from 5. 3 factorial. That is the number of arrangements that produce the same result. Okay. So that's how we figure out the number of bowls. In this case, we did 5p3 divided by 3 factorial. Now, so another way of writing 5p3 over 3 factorial, a lazy way of writing that is 5c3. The C stands for combinations. This is a combination problem. So we see that 5c3 gives us 10. Now, in general, if R things are drawn from n items without replacement, there are NCR ways to grab R items if the order in which the items are grabbed does not matter. We just came up with a formula for NCR, or a formula for if you have n flavors, how many ways can you choose R flavors to make a bowl of ice cream? Or how many bowls of ice cream can you make if you got n flavors and you want to choose R different flavors to make your bowl? We have a formula, NCR. It's NPR divided by R factorial. Now that's not the formula here. Turns out, using a little algebra, you can show that this formula, it's the same as this one. So you could see me in my office hours if you wanted, or you could go to the Math Learning Center or something like that, have it explained to you. So if you see this, it really is the same formula as this. You're just doing number of ice cream cones divided by the number of cones that correspond to the same bowl. All right. So in other words, NCR. It's a way. It gives you the number of ways to grab R things from n items, and it's the number of ways to grab R things from n items in which where the order in which the items grabbed does not matter. So if you're assembling an ice cream bowl with 3 different flavors, it doesn't matter how you put 3 different flavors in the bowl. You can eat any flavor you want first if it's a big bowl. So that's a combination problem. That's different from having an ice cream cone, which is a permutation problem. If you have 5 different flavors and you want to take 3 of them to put on an ice cream cone, that's different from having a bowl because the order in which you put the flavors on the ice cream cone does matter. The scoop you put on top has to be eaten first. So in that case, order did matter when we chose things. In the case of the ice cream bowl, order did not matter.